Now we know that how to use this present value table as we solved an example earlier. Now these are the rates which we call discount rates, right? And each of them is known as discounting factor for their relevant period and for their relevant rate. It is known as discounting factor. We can also calculate this discounting factor using a formula instead of seeing or instead of watching this table every time in the exam, because it will waste much of your time if you go back to check what should be the discounting factor for any specific rate and year. It can waste your time, so I will strongly suggest you to remember this formula, which is the part of discounting formula. As we know that the formula for discounting was present value is equal to future value 1 plus r and minus n. So this one is, using this equation we can calculate discounting factor, and trust me, it can save much of your time in your exam. So we will, for the next time whenever we will solve any question, we will use this formula instead of jumping back to refer to this present value table. Okay, now we will solve an example to understand it in a more better and clear way. So here we have an other understanding. What amount should be invested now to receive $10,000 in 4 years if the discount rate is 8% per annum? And we will solve it using both approaches, for example using formula and by using the table. Okay, to solve it I am going back to my Excel sheet. Okay, so here is our question, and here we have years, number of years, which is 4 years. It is our interest rate and it's our value. Now we will use two approaches to solve this question. For example, the first approach is, we will, according to first approach, we will use present value table, right? And under second approach we will use formula. Okay, let's do it one by one. First of all, we will do it using present value table, and then we will do it using formula. So here we have our answer. So here we have our value. We will multiply it with our discount factor, and then finally we will have, just give me a second. Okay, so then finally we will have our answer, or the discounted value. Okay, so we know that our value is 10,000. We will simply copy it. Now we know that we have to look for the discount factor in our present value table. And please remember, our discount rate is 8% and we want to look for the year number 4. So here we have 8% in our present value table, and we wanted to look for the specific year number 4, right? So it is the value that we will copy it, or instead, because it's a single value, I will prefer to write it 0.735. So here we have 0.735. I will simply multiply it with 1000. Here we have our answer. Okay, so now we will solve this example using formula, and we know that our formula is 1 plus r minus n. Okay, let's solve it according to this formula. So we have 10,000 as a value, then we want to multiply it with that formula. For example, 1.08 or 1 plus 0.08, and here we have the number of years 4. Fine. So you can see the answer in both cases are same, and it's more quick way to solve the question. Anyhow, we can ignore this point 3, which is a decimal figure. For the rest of the questions, we will prefer to solve our questions according to this formula. Okay, so now we have another concept of annuities. We have already discussed what is uneven cash flows in our previous lecture, where we discussed that these are nothing but different cash flows for each year. But the concept of annuity is different than uneven cash flows. It's totally opposite. Here we are expecting to receive even cash flows or same cash flow for each year. Let's see this example for better understanding. For example, a payment of 1000 is to be made every year for 3 years. The first payment occurs in 1 year time. The interest rate is 10%. Okay, what is the present value of annuity? So here you can see we are expecting same payment for each year. So it's the concept of annuity. We are expecting even cash flow for each year, and we are discounting it with their relevant discounting factor for each year. Like we are discounting in year 1, 2 and 3, and here we have the sum of these discounting factors. Fine. Now we can simply multiply it with 1000 and we can get this answer. In other words, we can say we can compute or we can calculate this figure using a formula which we will shortly discuss. Okay, and it will save our much time. In case let's say we have number of years, then in that case we have to multiply each year with its relevant discounting factor. But here in this case, if we can calculate annuity figure using our formula, then in that case we can simply multiply it to get our final answer. One more thing in this question, a very important point, you have to notice that the first payment is occurring in year 1. Okay, so it means that it's not occurring in year 0, because in year 0 the discount factor is always 1, but in year 1 the discount factor will be something else. So this information is very important in exam. You have to see that when your first payment is occurring, either it's occurring in year 1 or in year 0. If your examiner is telling you in your exam clearly that the first payment is occurring in year 1, then we will discount it like we are discounting it in this example. But if the examiner is telling you nothing, then we will always assume that our first payment is occurring in year 0. So it's an important point that you must remember. Just like the present value table, the examiner will also provide us this annuity table in our exam. But we have a problem with both of these tables. Both of these tables covers only a small range of discount rates, for example from 1% to 20% only. As you are already familiar with these tables, for example here we have discount rates and here we have the number of years. And in this case, because we are talking about annuity table, so each of them is known as annuity factor. Annuity factor. Now in your exams, the examiner may ask you to calculate annuity factor or discount factor of any specific discount rate which is outside this range. For example, the examiner may ask you to calculate the discount factor or annuity factor of, let's say, 25% discount rate. Then in that case, this annuity table or discount table, or we also say it present value table, will not be helpful during your exams. So at that moment we need a formula so that we can calculate anything outside this range. So I will strongly suggest you to remember this formula in order to save your time during exam. But in case if during exam if you forget this formula, then in that case you can come back to this table and you can see this formula right here. Okay, so when we will solve any question using this formula, then first of all we will solve this equation. Okay, we have already solved this equation when we were solving examples related to discounting factor. Okay, for example, now first of all we are calculating or solving this example, and now we get some answer. Okay, as the second step we will deduct this answer from 1, and again we will have some answer. Now at this time we will divide it by this r, or our discount rate, whatever the discount rate we have in the exam. Fine, so that's how we can calculate our annuity factor. Okay, so now we know that to calculate annuity factor we have two approaches. The first approach is we can use formula, and we can also use tables, but these tables covers only small range of discount factors. Okay, and to calculate using formula, first of all, let's say in this example we are using the discount rate of 10%. First of all we are solving this equation, this part of the equation. Okay, and then we are deducting it from 1, and then we are dividing it by r, and that's how we are getting our final answer. So it's our annuity factor in this example. Anyhow, there can be a small difference in the answer because of rounding off, so don't worry about it. Okay, so here we have an example. A payment of this amount is to be made every year. Okay, so these are same cash flows or even cash flows. That means we can use annuity factor here for 13 years. Okay, the first payment occurring is in year 1. The interest rate is 5%. Okay, fine. Okay, so we know what is our formula for this one to calculate our annuity factor divided by r. So here's how we will calculate our annuity factor: 1 plus 0.13. Okay, sorry, it is not percentage, it's years. It is 5%. 0.05 minus 13. So first of all we will calculate this equation, then we will less it from 1, and then we will divide it by 0.05, and then finally we will have some answer. I am not going to calculate it right now, you can calculate it later. Anyhow, whatever the answer come, we will simply multiply it with 11400, and we will get our final answer. These are the straightforward examples. Now we have another example related to annuities. Let's solve it. Okay, in this example we are expecting to receive $600 for each year for the next 5 years, and it's starting today. It means it's starting in year 0, not in year 1. Okay, interest rate is 10%. Find the present value of annuity. So we know that if something is coming in year 0, or if our first payment is occurring in year 0, then for that period our discount factor will always be 1. Fine, so we can say that we will not include our first year in the calculation of annuity factor. Fine, so as you can see in the solution, we are taking annuity factor of 4 years and we are ignoring the year number 0 in the calculation of annuity factor, and we know that what is the formula to calculate annuity factor. We have already studied it earlier. Fine. It's how we can calculate our annuity factor. So after calculating the annuity factor, we will multiply it with our value. Fine. We are multiplying it with 600, and that's how we are getting 1920. Okay. Then we are adding this 600 into this amount. Fine. We are adding this 600 into this amount, and here is our final answer. There is another way to include this amount, this 600, into this amount by slightly changing our annuity factor. For example, we can add 1 into our annuity factor to include this amount into our final amount. So in that case, it will be 4.17 if we add 1 into our annuity factor. Fine. And as a result, we will get the same answer as we are getting here. So these are the two ways by which we can get this answer. Anyways, the basic thing that we learned in this example is how to calculate annuities when our first payment is occurring in year 0. So in your exams, you have to give attention to this point, that when your first payment is occurring. Okay, till now we have covered the following topics. For example, compounding, discounting, and annuities. We have also covered their relevant questions. Here we want to predict the future value, so we have this formula to calculate that. Here we want to predict the present value, so we can do it using this formula. And here in the case of annuity, we can use this formula. Right. In the case of annuities, we expect to receive same amount of cash flows for some specific number of years. Same amount of cash flows for some specific number of years. Okay. But in case if we expect that we will receive these cash flows, let's say for foreseeable future, or in other words, for always, then in that case we can calculate the present value. We use the concept of perpetuities to calculate it. According to the concept of perpetuities, we expect to receive cash flows for foreseeable future or for ever. Fine. And how we can calculate its present value? We can calculate its present value simply using this formula: cash flows divided by R, or rate of return. But let's say we assume that there will be an increment of 10% each year in these cash flows. Okay, then in that case we can calculate the present value of perpetuities using this formula: cash flows divided by R minus G. We will understand it by solving few questions, but make sure you are not confused between both of them. Okay, in annuities we are expecting to receive cash flows, even cash flows, for some specific number of years. We know here that we are going to receive these cash flow, let's say for 3 years or for 4 years, etc. Okay, but in the case of perpetuities we are expecting that we will always receive these cash flows for foreseeable future or for forever. Okay, and here's how we can calculate the perpetuities. Okay, we will use this formula in the case if we are expecting an increment of some amount each year in these cash flows. Let's solve some examples for better understanding. Now we have a basic question related to perpetuity. A perpetuity of $2000 is due to commence immediately. It means the first payment will occur in year 0, and we will not include it in the calculation of perpetuity because for year 0 the discount factor will always be 1. Okay, the interest rate is 9%, and what is the present value? As we know, the formula related to perpetuity is cash flows divided by discount rate. So we can calculate it using this formula. Our cash flow in this case is $2000 and interest rate is 9% or 0.09. So as a result we can get this answer, right? As we know that we have not included the year 1 value in this amount, so we will include it in this value. So finally we will get the answer of 24222. As like previous questions, we can also include 1 in this formula to calculate this amount immediately. Okay, so it is how we can calculate it by adding 1. So these are two alternative methods by which we can calculate perpetuities. Here we have another understanding related to perpetuities. We have two different scenarios here, but the value and discount rate is same for both of these scenarios, but the only difference is there is no growth in the first scenario, but we have growth of 2% per annum in scenario number 2. So let's solve it one by one. So in the first case we will do it simply by using this formula. For example, 3000 divided by 0.1, and we will get 30,000 as a result. And in this case we have the growth of 2% per annum, so we will use this formula: divided by R minus G. G stands for growth. So we have the cash flow of 3000 divided by 0.1 minus growth of 2% means 0.02. So as a result we will get an answer of 37,500. I hope now you have a better understanding of perpetuity. Just remember one thing: using both annuities and perpetuities, what we are determining? We are determining the present value of future cash flows. Okay, these are some additional questions and these are your home assignment. Okay, I expect your answer after this class. Okay, so now we have delayed annuities and perpetuities. Everything is same as we studied earlier, nothing new here. But the examiner is trying to trick you with a little twist, just to check your understanding. But if you have a good understanding related to annuities and perpetuities, then it will not be a problem for you. Let's do the following examples for better understanding. What is the present value of $2000 incurred each year for 4 years? So here we have limited years. So that means it cannot be the case of perpetuity where we have infinite years. So it is related to annuities starting in 3 years time. Okay, so it's the twisting part. Starting in 3 years time. If the discount rate is 5%. So it means our first payment will occur in year 3. Fine. So the amount is $200 and years are 4. So here we have year 1, 2, 3 and 4. Fine. So we will take the annuity for these 4 years. Fine. For example, 4-year annuity factor according to 5% discount rate, and we will multiply it with 200 and we will have some answer here. Now whatever we will get the answer, we will discount it from this period to this period, or you can say we will discount it for these 2 years. Finally, we have some more questions related to delayed annuities and perpetuities. These questions are for your home assignment and I am expecting your answers after this class.